Welcome to the lesson on social and environmental considerations in design. In this video, we will explore how responsible design choices can impact society and the environment in meaningful ways. By the end of this lesson, you should be able to, first, analyze and evaluate social and environmental factors when making design decisions. Second, describe the ethical and legal responsibilities of designers. These outcomes will help guide your understanding of how design impacts people and the planet. What is sustainability in engineering design? It's more than just building something that works. Sustainability means creating designs that meet today's needs without harming future generations. In engineering, this involves using resources wisely, minimizing waste, and protecting both people and the environment. Sustainability in engineering design is often described as engineering with a conscience. It means thinking beyond functionality or profit. It's about designing with care for society, for the environment, and for the future. A sustainable design considers long-term impacts and aims to create solutions that are responsible and ethical. But what happens when engineering lacks conscience? Let's look at some examples of its effects. Polluted rivers due to improper waste disposal, communities displaced by poorly planned infrastructures, and products that harm users or the environment. These are just a few of the consequences when social and environmental factors are ignored in the design process. The United Nations Brundtland Commission defined sustainability in 1987 as sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. This means we must design with both today and tomorrow in mind, balancing human needs with environmental responsibility. A design or solution is considered sustainable if it is good for three key areas: the environment, by protecting natural resources and reducing pollution; the economy, by being cost-effective and supporting long-term growth; and society, by improving quality of life and promoting fairness and well-being. Sustainable development happens when all three pillars are balanced. Why is sustainability important in design? Because we're facing serious global challenges. These include the depletion of non-renewable resources, increased exposure to harmful chemicals, and the growing demand for clean water. We also see damage to ecosystems, rising amounts of waste, and the worsening effects of climate change. These issues drive the need for responsible and sustainable design solutions. Here's something to think about. One Earth is the total amount of natural resources that our planet can regenerate in a year, like fish from the oceans, trees from the forests, and nutrients from the soil. But today, humanity is using the equivalent of 1.75 Earths each year. That means we're using resources much faster than the Earth can replace them, an unsustainable path that puts our future at risk. So, what does using 1.75 Earths really mean? It means that it now takes the Earth 1 year and 8 months to regenerate what we consume in just 1 year. We are overspending our planet's natural budget. In short, humanity is using more ecological resources and services than nature can replace, causing long-term damage to our environment. This illustration shows the problem clearly. The Earth can regenerate the resources we use, like fish, forests, and land, at a rate of 1 Earth per year. But we are consuming and wasting resources at a rate of 1.5 Earths per year, or more. That's why Overshoot Day, the date when we've used up our yearly resource budget, came as early as August 8 in 2016. The message is simple: we are consuming faster than the Earth can regenerate. Overshoot Day marks the date when humanity has used up all the natural resources that the Earth can regenerate in 1 year. From that point onward, we are living on borrowed resources, damaging ecosystems, depleting reserves, and increasing waste. Each year, Overshoot Day arrives earlier, reminding us of the urgent need for sustainable design and living. Easter Island offers a powerful lesson about unsustainable resource use. Its history shows how a once thriving civilization collapsed after exhausting the natural resources it depended on. Click the link to watch the video and reflect. What went wrong, and what can we learn from it today? Let's now talk about two important terms. Ecological footprint is a measure of how much natural resources a person, community, or business uses to support their lifestyle or activities. Biocapacity, on the other hand, is the Earth's ability to supply those resources and absorb waste. When our footprint is greater than the Earth's biocapacity, we are in ecological overshoot. Take a look at the map. The countries in red are in what we call an ecological deficit. This means they use more natural resources than their ecosystems can regenerate. In other words, their ecological footprint is greater than their biocapacity, an unsustainable path that puts pressure on both local and global environments. This graph shows the world's ecological footprint from 1960 to 2008 and two possible futures through 2050. The pink line shows how resource use has steadily increased, reaching over 1.5 Earths. If we continue with business as usual, shown in red, we may need nearly 3 Earths by 2050. But with rapid reduction, shown in orange, we can move toward sustainability and live within the planet's limits. The choice is ours, and it starts with responsible design and daily decisions. Let's apply what we've learned. How many Earths would we need if everyone lived like people in your country? Here's an example. In 2018, Japan's ecological footprint was 4.6 global hectares per person, but its biocapacity was only 0.6. That means Japan would need 7.8 Japans to sustain its way of life. Now it's your turn. Try calculating how many Earths your country would need. You can also explore how different countries compare. Think, are we living within our limits? This chart shows how many countries each nation would need to sustain its way of life. For example, if everyone on Earth lived like the average person in Japan, we would need 7.9 Japans to meet the demand. Italy would need 5.3 Italys, and Switzerland 4.4. Even the world average is unsustainable. We're using the equivalent of 1.75 Earths. Some countries, like India and France, have lower ecological footprints, but even they must strive for balance. This comparison reminds us, sustainability is a global responsibility, and design plays a key role in that future. So how many Philippines would the country need to support the lifestyle of its own people? The answer is 2.9 Philippine archipelagos to meet the residents' demand on nature. And if everyone on Earth lived like Filipinos, we would still need 0.9 Earths, which means we are just below the global ecological limit. This shows that while the Philippines' footprint is lower than many countries, there's still room for improvement and a need to protect our natural resources. Sustainability is built on 3 essential elements: environmental sustainability, protecting nature and using resources wisely; social sustainability, ensuring equity, health, and well-being for all people; and economic sustainability, supporting growth and innovation without harming future generations. A truly sustainable design must consider all 3. Engineering sustainable development means finding the right balance between 3 elements. Economic, understanding costs and building sustainable businesses that provide needed services. Environmental, considering how our designs affect the planet and its limited resources. And social, ensuring our solutions improve people's lives and meet community needs. Where these 3 overlap is where true sustainable development happens, and that's where good design should aim. So how can we apply sustainability in real-world design? Economically, we can develop processes that make use of industrial waste instead of paying to throw it away. Socially, we should design products that don't unfairly impact one group of people. And environmentally, we must create systems that reduce pollution and conserve resources. Sustainability isn't just a goal, it's a mindset we apply in every step of design. Environmental engineering offers solutions for the past, present, and future. Fixing the past means cleaning up contaminated sites through remediation. Dealing with the present involves treating dirty wastewater or emissions before they cause harm. And planning for the future means designing systems that prevent pollution from happening in the first place. Together, these approaches help build a cleaner, safer, and more sustainable world. Let's watch the story of solutions. This short video explores what it really means to solve problems in a way that's good for people, the planet, and the future. Click the link to watch and think about how you can be part of designing better solutions. How can we tell if a product or service is truly sustainable? One powerful method is called life cycle assessment, or LCA. It audits the total impact of a product from beginning to end, starting with raw materials, then moving through manufacturing, packaging, transportation, usage, and finally, disposal. By analyzing every stage, we can make better decisions and design products with less environmental and social impact. Let's look at the life cycle assessment of a generic smartphone. This bar graph shows the total carbon footprint in kilograms of CO2 equivalent. Most of the emissions, 50 out of 65 kilograms, come from the production stage alone. The rest come from usage, transport, and disposal. This tells us that what happens before we even use the device has the greatest environmental impact. When we zoom in on the production stage, we see what's driving that high carbon footprint. The largest contributors are memory ICs, other integrated circuits, and printed circuit boards. Even packaging, solder paste, and battery manufacturing add to the total impact. This breakdown helps engineers and designers make better choices, like sourcing cleaner materials or improving energy efficiency in production. Let's end with some inspiring examples of sustainable engineering in action. First, wind turbines. The Bahrain World Trade Center is the first commercial building to integrate horizontal axis wind turbines directly into its structure. These turbines generate 675 kilowatts of power, supplying over 15% of the building's energy needs. Next, solar panels. The Kurilpa Bridge in Australia is the largest footbridge powered entirely by the sun. Its solar-powered LED lighting system saves nearly 38 tons of carbon emissions each year. These projects prove that with smart, sustainable design, we can build a better future, starting today. Here are more examples of sustainable design thinking in action. Piñatex is a leather alternative made from pineapple leaves, an agricultural waste product. Developed by Ananas Anam, it's processed in the Philippines and used in clothing, shoes, and even furniture, offering a cruelty-free, plant-based material. Current Window is a project by Dutch designer Marjan van Albel. These beautiful stained glass-like windows are made of colored solar cells that generate electricity to power small devices, blending sustainability with aesthetics. And finally, edible six-pack rings. Saltwater Brewery created packaging that marine animals can safely eat. Made from leftover wheat and barley from brewing, they replace harmful plastic with something wildlife-friendly and biodegradable. Engineering design is evolving. In the past, engineers focused mainly on technical solutions, solving problems quickly, with little concern for environmental impact. But today's challenges require a new kind of engineer, one who can evaluate both technical and non-technical solutions, solve problems not just for today, but also for the future, and collaborate across disciplines, working with scientists, designers, and communities to build more sustainable systems. The future of engineering is not just about innovation, it's about responsibility. Engineers are shaping the future, and the decisions they make today will impact generations to come. With the Earth's resources being limited, we all have a role to play. Future engineers must be trained not just in technical skills, but also in making ethical decisions that protect the environment, promote social justice, and serve the needs of all people through a sustainable global economy. So ask yourself, how can you help? Whether as a future engineer, designer, or informed citizen, your choices matter. Let's take a closer look at a real and ongoing issue, the Kaliwa Dam project in the Philippines. Proposed as early as 2012, it aims to solve Manila's growing water supply problem with a capacity of 600 million liters per day. But it also raises major concerns. Is it worth the cost to taxpayers? Will it increase the risk of flooding in downstream areas? Could it disturb local biodiversity or displace indigenous communities? This case challenges us to think like responsible designers. How do we balance human needs with environmental and social impacts? What makes a solution truly sustainable? Now let's ask a crucial question. Is the Kaliwa Dam project ethical? While it aims to address Manila's urgent water supply needs with a capacity of 600 million liters per day, it also raises serious concerns, like the displacement of indigenous peoples, destruction of biodiversity in Sierra Madre, and the use of taxpayer money. There's also the risk of increased flooding in downstream communities. On the other hand, some argue that it's a necessary solution to avoid a future water crisis. As future designers, engineers, and decision-makers, you must learn to weigh technical feasibility with ethical responsibility. What do you think? Does this project serve the greater good, or does it sacrifice too much? To understand whether a project is ethical, we need to understand ethics itself. Ethics is the study of morality and the moral choices we all make in life. It helps us decide what is right or wrong, good or harmful, not just for ourselves, but for others and for the planet. In engineering and design, ethics guides us to ask, who benefits, who is harmed, and are we making the most responsible choice for everyone involved? Why is ethics so important in engineering? Let's compare two professions. An unethical surgeon might risk the life of one person, or two in rare cases. But an unethical engineer, by cutting corners or ignoring safety, could endanger hundreds of lives, like in the case of a poorly designed bridge. This shows that engineers don't just work with materials, they work with human lives. That's why ethical responsibility must be at the core of every decision an engineer makes. In some jobs, mistakes can be tolerated, like a wrong order in a restaurant. They're inconvenient, but they rarely cause real harm. But in engineering, a single mistake or an unethical decision can cost hundreds of lives. A faulty bridge, a weak building, or a poorly designed system can have catastrophic consequences. That's why, as future practicing engineers, you are expected to uphold the highest standards of honesty and integrity. Your skills will shape the world, but your ethics will determine whether that world is safe, fair, and sustainable. As future engineers, you are bound by a professional code of ethics that guides your decisions and actions. You must hold paramount the safety, health, and welfare of the public. Perform services only within your area of competence. Communicate truthfully and objectively. Act as loyal and trustworthy agents for your clients or employers. Avoid deception of any kind, and always conduct yourself with honor, responsibility, ethics, and integrity. This is not just a guideline. It is a lifelong commitment to use your skills for the greater good. Let's pause and reflect. Are all designs automatically good just because they work? Not necessarily. Some designs may function well but still cause harm to people, the environment, or even society at large. So how do we judge what makes a design truly good or what makes it flawed? This is where ethics becomes essential. Ethical thinking helps us assess not just how something works, but who it affects, what it costs, and what values it upholds. Design isn't just about solving problems, it's about solving them responsibly. Let's explore the ethical side of design through some real examples. Ask yourself two important questions. Who does the product really benefit, and how does it benefit them? Take Ringly, for example, a stylish smart ring that alerts the wearer to texts, emails, and calls. But who benefits from this design? Mostly tech-savvy consumers who can afford an iPhone and an extra $200 for convenience. Next, the Coolest Cooler. It plays music, charges devices, mixes drinks, and costs $400. It's fun, but who does it serve? Primarily those with the luxury of leisure time and disposable income. Finally, consider Super Bananas. These genetically engineered bananas are enriched with vitamin A to help prevent blindness in children across sub-Saharan Africa. This design directly addresses a life-threatening problem and benefits communities in real need. So not all designs are created equal. Some may be clever or trendy, but others truly solve urgent global challenges. Ethical design asks us to prioritize impact, not just innovation. When thinking about ethical design, we can't stop at what the product does. We also need to ask, how was it developed and tested, and who makes it? History shows us troubling examples, like children working in factories before labor laws existed, or prisoners, including children, being subjected to horrific medical experiments during the Holocaust. Today, unethical practices still exist, such as child labor, unsafe working conditions, and unfair wages in some supply chains. As future engineers and designers, it's your duty to ask, are the people involved in making this product treated with fairness, dignity, and respect? Because truly ethical design considers people at every stage. Here's something to think about. What happens when technology like 3D printing is used to create weapons? Click the link to watch the video in your free time. As you watch, ask yourself, is this a responsible use of design and technology? Where do we draw the line between innovation and danger? Ethics in design is not always black and white, but it's always important. Ethics in design goes beyond physical products. It touches all areas of modern life. Here are some other pressing ethical issues we face today. Job displacement. As automation and AI take over tasks, what happens to the workers? Misinformation. How do we stop the spread of fake news that can influence public opinion and harm society? Privacy concerns. Who controls your data, and how is it being used or tracked? Cybersecurity risks. With growing reliance on digital systems, how do we protect against hackers and data breaches? AI errors and bias. What if an algorithm makes a wrong or unfair decision? Military robotics. Should machines be allowed to make life or death decisions in warfare? Superintelligence. If artificial intelligence surpasses human intelligence, what are the risks? As future thinkers, designers, and engineers, you are entering a world full of opportunities and ethical responsibilities. The question is, what kind of future will you help design? As we've seen throughout this lesson, technological advancements bring incredible possibilities, but also serious ethical challenges. In many cases, emerging technologies have exposed moments where ethical principles were ignored or compromised. These examples remind us why it's essential to assess innovations thoroughly, to weigh both their benefits and potential risks. As future engineers, designers, and changemakers, always ask, just because we can build it, should we? Let ethics guide your innovation for a future that is smart, sustainable, and just. Let's put your learning into practice. On a one whole sheet of paper, answer the following. Choose a specific product or service that you regularly use. Reflect on how this product or service benefits individuals or society. Does it improve convenience, safety, health, or overall quality of life? Then ask yourself, are there any unethical issues involved in its design, production, or use? Be honest and thoughtful. This activity will help you connect real-life technology to the ethical ideas we've explored today. Thank you for joining this lesson on social and environmental considerations in design. As future engineers, innovators, and responsible citizens, always remember, good design is not just about solving problems, it's about solving them ethically and sustainably. Keep asking questions, keep reflecting, and most importantly, keep designing with a purpose. Until next time, stay curious, stay critical, and stay committed to building a better future.